Hello everyone and welcome to Applied Mathematics and Calculus tutorial. In this tutorial, we explain how to sketch a function involving an absolute value of some other function. The problem solved in this video tutorial is very important for students who want to master basic and advanced calculus topics, as well as for students who want to prepare themselves for the Advanced Placement Calculus exam, that is, for the AP Calculus exam. Before we start with explanations, we need to mention that all engineers, physicists, and scientists need to know how to sketch basic functions by hand. This is a fundamental skill that is necessary for engineering profession. Furthermore, by learning how to sketch a function, one can obtain a deep and intuitive understanding of mathematics and behavior of functions. Finally, before I start with explanations, I have to mention that it took me a significant amount of time, energy, and planning to create this completely free video tutorial, as well as more than 300 free video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot! We will solve this problem by using two approaches. The first approach is an approach that a very experienced person would use. That is, with very little calculations, we will almost immediately sketch the graph. The second approach is a systematic approach that completely relies upon calculus and calculations. My suggestion is to use the second systematic approach, and only after you gain enough experience you should use the first approach. Here is the first approach. Let's first sketch a coordinate system. Here it is. Here's y, and here's x-axis. X and y. Let us first sketch the function y is equal to x squared minus 4. Obviously, this function has zeros at 2 and at minus 2. Then, when x is equal to 0, this function is minus 4. Consequently, let's sketch the point minus 4. Here it is. And let's sketch the function x squared minus 4. I will use dashed lines. Here's the function. It is a parabolic function that looks like this. We know that the function is oriented like this since x squared is positive. That is, we have here plus sign. Okay. Now we are ready to sketch the function absolute value of x squared minus 4. We need to apply the absolute value to the function y is equal to x squared minus 4. When this function x squared minus 4 is positive, absolute value is not doing anything. That is, it just returns the values of the function. Consequently, our absolute value function, that is this function over here, will look like this when our function x squared minus 4 is positive. That is, we need to use this branch. Similarly, over here, the function x squared minus 4 is positive, and consequently, this function will look like this for the values larger than 2. Perfect. Now, what is happening over here? The function y is equal to x squared minus 4 is negative. If we take the absolute value of negative part, we will simply mirror the negative part with respect to the x-axis, and consequently, we will obtain this branch. And here it is. Our function absolute value of x squared minus 4 is sketched by the black line over here. It goes like this, goes down, goes down, goes down, then it goes up, goes up, goes up, reaches its maximum, goes down, then again it goes up, etc. And here it is. This was the first approach. Next, let's explain the second approach. Here's our y and here's our x. But before we sketch this function, we need to recall the mathematical definition of the absolute value. Let us consider this function. Y is equal to absolute x. This function is actually defined like this. It's equal to x when x is larger than or equal to 0, and it's equal to minus x when x is smaller than 0. Obviously, this function looks like this. This is x, this is y, and it resembles the V letter. It looks like this. Now, let us apply this definition of absolute value to this function over here. We have y is equal to absolute value of x squared minus 4, and this is equal to, let's see, this is equal to x squared minus 4 when x squared minus 4 is larger than or equal to 0. And this function is equal to minus x squared plus 4 when x squared minus 4 is smaller than 0. To complete this definition, we need to see when this function x squared minus 4 is larger and when this function is smaller than 0. Let's sketch a graph over here. Our function y is equal to x squared minus 4 looks like this. Here it is. The zeros are at minus 2 and 2, and this value is minus 4. Obviously, this function is positive over here, it's negative over here, and again it's positive over here. Now, we can use this graph to complete this definition. Over here, we need to basically add the bounds. For x larger than or equal to 2, this function x squared minus 4 will be larger than or equal to 0. And for x smaller than or equal to minus 2. Perfect. How about this part? Obviously, over here, the function y is equal to x squared minus 4 is smaller than 0 for x in the interval from minus 2 to 2. Perfect. And this is definition. We have that this absolute function is equal to x squared minus 4 for x larger than or equal to 2 and for x smaller than or equal to minus 2, and this function is equal to minus x squared plus 4 for x in the interval minus 2 to 2. Perfect. Consequently, we can consider two cases. We have case 1. In case 1, y is equal to x squared minus 4, and this is valid for this interval and this interval. And we have the second case, y is equal to minus x squared plus 4 when x is in this interval, minus 2 to 2. Perfect. Now we are almost done. First, we will need to denote the bounds. That is, we need to denote the intervals. We have minus 1, minus 2 over here, and over here we have 1 and 2. Over here I will also need 1, 2, 3, and minus 4, and I will need 1, 2, 3, and 4. Perfect. Let's see. When x is smaller than or equal to minus 2, our function looks like this. That is, we will have this branch. And when our function is, when actually x is larger than or equal to 2, we will have this branch. These branches are simply the branches of this function. However, when x is in the interval from minus 2 to 2, our function will look like this. That is, it will look like this. And that's it. That's the solution. This was the second approach. Let's analyze the second approach. What did we do in the second approach? First of all, we resolved these absolute values. Then we looked for intervals of x for which this part is larger than or equal to 0 and smaller than 0. And then we kind of decomposed the function depending on segments, and then we sketched the function for each segment. And that's it. Okay, that would be all for today. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thanks a lot and have a nice day.